Hello students, in today's lecture we will discuss about significant figures, that what are significant figures and how you can determine the value of significant figures. Okay, first of all we should see the definition. The meaningful digits which are known with certainty plus one uncertain or estimated value. Okay, let's discuss this significant figure with an example. Okay, there are three students who measures the length of rod okay. According to student 1, the length of rod is 91.62 centimeter. Okay, and according to student 2, the length is 91.61 centimeter, and student 3rd observe the length 91.63 centimeter, right? There are three digits that are common in each student's measurement. Okay, 91.6. Okay, it is common in every student's measurement. Okay, so this value is known as certain value. Okay, that means this value is confirmed value. Now these digits are different in every student's calculation, so this digit is known as doubtful value, right? Now the uncertainty observed in the experimental value and analytical value. Okay, definitely I know that the length of this rod is in between these values. Let's see, the length is none other than that is 91.62 centimeter, right? But these three digits are similar in everybody's calculation, but this digit is not similar in every student's calculation, so this digit is doubtful value in case of every measurement. So the doubtful or certain digits are determined with the help of significant figures. So what we can say, the uncertainty observed in the experimental values and analytical value is indicated by significant figures. That means if I am having any calculation, in that calculation I'll have certain values, there will be some certain values, plus there will be one uncertain or estimated value with which I can determine the value of significant figures, right? Okay, to determine the value of significant figures, these are some rules. Okay, let's go through the first rule. All non-zero digits are significant. Okay, if you are having any value, I am having 91.62. Okay, here I am having all non-zero digits, so every digit present in this value is significant in nature. So you can write 1, 2, 3, 4. So there are 4 significant figures in this value. Right? Now next one is 0 preceding to first non-zero digits are not significant. Okay, if you are having 0 with first non-zero digit, that is not significant in nature, right? If I'll write 0.00062, right? Here 0 is preceding to the first non-zero digit is not significant in nature. That means zeros present on the left side of the significant figure is not significant in nature. Okay, so you can write here we are having two significant figures. right? Now next one is zeros between two non-zero digits are significant in nature. If you are having zero in between two non-zero digits, or you can also say zeros present between two significant figures are always significant, right? So I'll write 8008, right? Here I am having two significant figures, and in between two significant figures we are having zeros that are also significant. So here we are having four significant figures, right? Now next one is zeros at the end or right of a number are significant provided they are on the right side of the decimal point. Okay, if you are having zeros at the end or right of a number, okay, let's take an example. That means if I am having 230.238.000, here zeros are present on the right side of the decimal point, right? So these zeros are significant in nature. So you can write 1 2 3 4 5 6. So here we are having 6 significant figures, right? There is one more thing. If I am having any zero in between the significant figures, that means if I am having 500.0, right? Here I know that zero present on the right side of the decimal point is significant in nature. That means this zero is significant. This value is also significant in nature. So zeros present in between the significant figures are also significant in nature. So what can I say? There are four significant figures. Okay, but if I am not having any decimal over here, that means if I am having only 500 here, so that means zeros is always insignificant or non-significant in nature. So what I can say, I am having only one significant figure over here. That means if I am having any zero in between the significant figures, definitely these zeros are also significant in nature. There is one condition that if you are having zero, that should be on the right side of the decimal. If you are having any zero present on the left side of the decimal, that zero is insignificant or non-significant in nature, right? Now next one is counting the numbers of objects have infinite significant figures. Counting the numbers of object means if you are having 3, right? This 3 is significant in nature, but it will have some value, like this 3 is having one significant figure, right? But what if I'll write 3 balls, or you can say 2 pens? Now you define this numeric value. That means there are 3 balls present over here. So what you can do, you can write infinite zero with this value. So that means if you will define any value according to the object, definitely that value will have infinite significant figures. So what you can say, there are infinite significant figures. Okay, last rule that is also very important. If you are having any exponential value, that means if I am having 3 into 10 raised to power 8, here I am having exponential value. This exponential value is non-significant in nature. So how many significant figures are there? There is only one significant figure. So you can write there is only one significant figure. So students, this is NCRT problem present on page number 26 and it is problem number 1.19. Okay, let's see the statement. How many significant figures are present in the following? Okay, you are having some values, and in these values you have to find the number of significant figures. Okay, so let's start with the first one. You are having 0.0025. So in this value we'll see the rule. So according to the rule, the zeros present on the left side of the non-zero digit is always considered as insignificant figures. So how many significant figures are present? There are only 2 significant figures present. So I'll write 2 significant figures. Now in this question they have given you the value 208. Okay, now the zeros present between the two non-zero digits are always significant. So how many significant figures are present? There are 3 significant figures present. Again, we are having 0 in between the 2 non-zero digits. So there are 4 significant figures, right? Now, what they are saying, according to the rules, if I am having any value, any 0 present on the left side of the decimal, these zeros will be considered as insignificant in nature. So if I'll put decimal over here, these zeros are insignificant in nature. So how many figures are present over here? There are only 3 significant figures, right? Now I'm having a 0 on the right side of the decimal. That means this 0 is significant in nature, and zeros present in between 2 significant figures are always considered as significant in nature. So how many significant figures are present? 1, 2, 3, 4. So we are having 4 significant figures. Now zeros in between the non-zero digits or significant figures are always considered as significant. So how many significant figures are there? 1, 2, 3, 4, 5. So there are 5 significant figures. Okay guys, how we can process addition and subtraction of significant figures? So there is a very basic rule that we should know. So let's read the rule first. When addition or subtraction is to be carried out, if you want to carry out addition and subtraction of any significant figure, the final result should be represented up to the same number of decimal places. Your final result should be represented according to the same decimal places as are present in the terms having the least number of decimal places. Your answer should be according to that term who is having the least number of decimal places. Okay, so let's write an example. If I want to add 7.230, okay, 2.1, 0.312, okay. So if I want to add these values according to the significant figure, so my answer should be in terms having the least number of decimal places. So in these 3 values, who's having the least number of decimal places? Here 2.1 is having only 1 decimal place over here, right? So I'll express my answer according to this value. That means I should have 2 significant figures in my answer only, right? So let's add these values. So 0 plus 2, that means I'm having 2. 3 plus 1, that means 4. 2 plus 1 plus 3, that means 6 point, right? 7 plus 2, 9. So my answer is 9.642. But according to the rule, what I have to do, I have to express my answer in the terms having the least number of decimal places. So what I'll do, I'll simply express my answer according to this value. That means I have to express my answer in 2 significant figures. Okay, so my final answer is 9.6. Now let's take one more example. I want to add 89.232 plus 1.1, right? Here who's having the least number of decimal places? 1.1 is having least number of decimal places. That means on the right side of the decimal there is only 1 digit, right? So whenever I'll express my answer, I'll express according to this value. So let's calculate this value. 2 plus 0, that means 0. 3 plus 0, that means 0. 2 plus 1, 3. 9 plus 1, 0. 10 and I'll carry 1 over here. 8 plus 1, 9. So my answer is 90.332. But I have to express my answer according to this value. So my final answer will be 90.3. Why? Because I have to see that the term should have least number of decimal places. Here 1.1 is having 1 digit on the right side of the decimal place. So I should have my value according to that. So there will be 1 digit on the right side of the decimal place, right? So let's take one more example. So I want to subtract 25.4630. I want to subtract 24.31. Okay, so on the right side of the decimal there are two digits, so I have to express my answer according to these two digits, right? So I know that 0 minus 0, that means 0, 3 minus 0, 3, okay, 6 minus 1, 5, 4 minus 3, 1, 5 minus 4, 1, 2 minus 2, 0. Okay, so my final answer is 1.1530, right? Here I'm having two decimal digits on the right side of the decimal. Okay, I have to express my answer according to that. So my answer will be 1.15. That is my final answer. So students, the rules for multiplication and division of significant figures are also same, just like addition or subtraction. So let's read the rule first. According to the multiplication and division rule, in multiplication or division, the final result should be reported up to the same number of significant figures as are present in the term with least number of significant figures. Okay, again, if you are multiplying or dividing any of the values, what you have to do, you have to express your answer according to the terms with least number of significant figures, right? So let's take an example. Here I want to multiply 5.1028 with 1.3, right? Okay, let's write 1.30. Okay, if I want to multiply these two values, I have to express my answer according to this value. That means on the right side of the decimal, I should have two digits only in my answer, right? So if I'll multiply 5.1028 with 1.30, my answer is 6.63364. But according to the rule, I have to express my answer up to two digits on the right side of the decimal. So my final answer is 6.63. Let's take one more example. If I want to divide 5.2765 with 1.25, okay, here I am having two digits on the right side of the decimal, right? So if I'll divide these two values with each other, my answer is 4.2212, but my answer according to the rule should be two digits on the right side of the decimal. So my final answer is 4.22. That is my final answer. Okay students, I know that if I'll multiply 2.5 into 1.25, my answer should be restricted up to one digit on the right side of the decimal according to the rule, right? So my answer will be 3.125. Okay, since 2.5 is having two significant figure and one significant figure on the right side of the decimal, so the result should not have more than two significant figures. That means there will be only one significant figure on the right side of the decimal. So the answer is this. Okay, while restricting your result to the required number of significant figures as done in the calculation, there are certain rules that you should keep in mind. Okay, so let's go to the first rule. According to the first rule, if the digit coming after the desired number of significant figures happens to be more than 5, the preceding number is increased by 1. Okay, so I'll take one example. For example, if I am having a value 1.386, I want to make this value up to 3 significant figures. That means these 3 significant figures should be present over here. But if I want to have these significant figures, there are certain things that I should keep in mind. So if I am having any value more than 5, the preceding number, that means this number should be increased by 1. That means here I am having a digit on the right side of the preceding number. So what I'll do, I'll simply increase my preceding number with 1. So the resultant answer is 1.39, right? Now let's have one more example. 4.89. I want to restrict my calculations up to two significant figures. That means these two significant figures should be present in my answer, right? So to round off this value, what I'll do, I'll simply see digit present on the right side of the preceding number is more than 5 or less than 5. If it is more than 5, what I'll do, I'll simply add 1 in this preceding value, right? So my answer is 4.9. Okay, can we go for the next rule? What they're saying, if the digit coming after the desired number of significant figures happens to be less than 5. Okay, I'll again explain with example. If I am having a value 4.334, I want to express my answer up to 3 significant figures. That means up to this value, right? If I am having any value that is present on the right side of the preceding value is less than 5. 4 is less than 5. What I'll do, I'll simply write my value according to their actual state. Okay, I'll not change any value, I'll not change preceding value. So what I'll write, 4.33, right? Let's take one more example, 6.213, right? I want to express my answer up to 2 significant figures. That means up to this value, right? So this is my preceding value. Okay, what I'll do, I'll see the value next to the preceding value. Here I'm having 1, so 1 is less than 5. So what I'll do, I'll simply write my preceding number without any change. So my confirmed answer is 6.2, right? So let's go for the next one. If the digit coming after the desired number of significant figures happens to be 5, okay, now if you are having any digit present over here is 5, then preceding number is increased by 1 only in case of odd. Okay, so let's see, if I am having value 6.235, right? Here I want to restrict my calculations up to 3 significant figures, right? So that means this is my preceding value. Okay, what I'll do, I'll see next value on the right side. It is 5 and I'm having preceding value in odd term. Okay, so what I'll do, I'll simply increase this value by 1, right? So it will be 6.24. Okay, can we take one more example, 9.15. Now I want to restrict my value up to 2 significant figures. Okay, so these are 2 significant figures. I'll see my preceding value, and on the right side of the preceding value there is 5, right? Now my preceding value is odd number. So what I'll do, I'll simply increase the preceding value by 1. So 9.2 is the final answer. Okay, what if I am having even number? In case of even number, the preceding number remain unchanged, right? So if I am having value 9.25, okay, now I want to restrict the value up to 2 significant figures. Here I am having even number, okay, and preceding value, if preceding value is even number, I'll write the value without any change. So the answer is 9.2, right? Let's take one more example, 8.45, right? I want to restrict this value up to 2 significant figures. Okay, here this is my preceding value. Okay, on the right side of the preceding value there is 5. Okay, so preceding value is even in nature. So what I'll do, I'll simply write the values without any change. Students, this is NCRT problem 1.20 present on page number 27. Okay, let's read this statement first. Round up the following up to 3 significant figures. Okay, you are having some values, and what you have to do, you have to express these values up to 3 significant figures. That means first of all, I'll write my preceding values. Here I'm having 3 significant figures, so this 2 is my preceding value. Okay, I have to express my answer up to this value, right? So what I'll do, I'll simply check the digit present on the right side of the preceding value. Okay, it is less than 5. So what I'll do, I'll simply write my preceding value without any change. So the final answer is 34.2, right? Now again I have to check the value up to 3 significant figures. Okay, the zeros present in between the significant figures are always significant in nature, so this 0 is significant. So I am having 1, 2, 3 significant figures. Okay, now this is my preceding value. What I'll do, I'll simply check the digit present on the right side of the preceding value. So it is 1 less than 5. So what I'll do, I'll simply write the value as it is, 10.4, right here. Now, according to the rule, the zeros present on the left side of these significant figures are always non-significant in nature. So, these two zeros are non-significant in nature, right? So, my significant figures are 4, 5, 9 if I want to express up to 3 significant figures, right? So, this is my preceding value, and on the right side of the preceding value there is 7, that means more than 5. So, what I'll do, I'll simply add 1 here in 9. Okay, so if I'll add 1 in 9, it will be 10. Okay, it will give its 1 to this 5, and the value will be 0.0460, right? Now, next one is 2888, and I want to express my answer up to 3 significant figures. Here it is my preceding value. So what I'll do, I'll simply check the value present on the right side of the preceding value. It is more than 5. So what I'll do, I'll simply add 1 in the preceding value. So 289 is my final answer. So students, I am having value up to 4 digits. So what I have to do, I have to add a 0 over here so that the value will be 4 digits. Although I know that the digit present over here, that means 0 present over here, is not having any significance in this value.